This is AS Pure Mathematics. We're looking at algebraic division, which goes alongside Chapter 10 in the Pure Notebook and can be used with factor remainder theorem and factorising cubics. So if we look at this example, divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. I'm going to look at method 1, comparing coefficients. Once you have practiced this method, you might be able to do it without writing anything down, which would be great because obviously that's going to speed you up. So the first thing is setting this out here. So we've got x cubed, that's the question, that's a polynomial in the question. It is cubic, and if I divide it by x minus 3, then I am going to end up with a quadratic bracket. And all you need to do to work out what this power is going to be here is take the highest power of the polynomial and then the highest power that you're dividing by, and then just using indices. If I do x cubed divided by x, I get x squared, and that tells us what this polynomial looks like. Even if you have terms missing, so even if you had an x squared or an x term missing, it would still take all of the terms in this bracket. If it's not required, then one of the coefficients will end up being 0. And I'm putting the plus d on the end because at this point I don't know if I've got a remainder, so I don't know if x minus 3 is a factor. So the first thing we're going to do is find d. So how do we find d? Well, using the remainder theorem, if I take that bracket and set it equal to 0, so the thing that I'm dividing by, set it equal to 0 and find x, and then I need to substitute it in. So x equals 3 would make that bracket 0. So we've got 3 cubed plus 2 times 3 squared minus 17 times 3 plus 6, which is equal to 0. And the reason we're doing that is if I make that bracket there 0, when I substitute it in, because remember this sign here means identity, so it means the left hand side is equivalent to the right hand side. When I substitute that into here, it cancels all of that out because anything times by 0 is 0, which would just leave me with d. So that's why that is working. If you kind of think of substituting the 3 into both sides. So d is equal to 0, and therefore x minus 3 is a factor by the factor theorem. So what I'm going to do is I'm going to take this and I'm going to expand it. So maybe pause the video and just have a go at expanding this bracket out here on the right hand side. Once it's expanded, it looks like this. So that's just doing ax squared times x, ax squared times minus 3, and I get this expression here. And I'm going to rewrite that and I'm going to colour code it. And the reason why I've done the colour coding is because I want to do comparisons. So if you just pause the video again and just look at the colour coding, you should be able to see the cubic, the quadratic, the linear terms and the constant term. So I've got them written in that order. And then all we need to do is compare. So if I look at the cubic, if these two things are equivalent, I know that a has to equal 1 because I need it to be x cubed. So a has to be equal to 1. Then if I look at the quadratic, if I take the coefficient of the quadratic, I end up with minus 3 plus b. And the reason for that is if we factorise, if I just take this green section here and I factorise out an x squared, then I would have minus 3a plus b. So and that would be the coefficient of x squared. So that's taking out the x squared, and I know that that term then has to equal 2. So that's what we're working with there. So then when we look at that, compare the coefficients, I get minus 3a plus b equals 2. Well, I know that a is equal to 1, so I can substitute that into here. So that's where that minus 3 has come from, and then solving the equation leads to b is equal to 5. Repeat. So now I want minus 3b plus c to equal minus 17. So comparing the coefficients of x, I get that equation. I've got minus 17 is equal to minus 15 because b is equal to 5. So I can substitute 5 into here. Solving this equation here leads to c equals minus 2. And then finally, we can check that this bit works. So when I substitute c equals minus 2 into here, I end up with 6. And therefore I can check that that's worked. I've got c equals minus 2 again just by comparing the constant coefficients. Therefore, we have x cubed plus 2x squared minus 17x plus 6 can be written as x squared plus 5x minus 2 brackets x minus 3. If you are asked to factorise a cubic, you would then proceed to factorise that quadratic in the way that you always have since GCSE. So in this case, it's not going to factorise, so I'm going to stop at this point. But you can get 2 further brackets out of that in some cases. If you need to go back over that video, then please do so and just pause it and make sure you understand each line. And it's practice if you want to get this sorted. You need to be fluent in this. Looking at this in a slightly different way is the grid method. So we would start off thinking about whether we need a remainder or not. Often the question guides you through, so it might say show that x minus 3 is a factor. If I was trying to show that x minus 3 was a factor, I would do this piece of working and then just need to write a conclusion on the end where I'd say that this is equal to 0, therefore x minus 3 is a factor. If I'm just asked to factorise something, then it's a case of finding what this x minus 3 is, which we'll look at in a little bit more detail later. So I'm going to set this up as a grid method. So you should have seen this or may have seen this when expanding brackets at high school. It's exactly the same as the other method, but it's just being written in a slightly different way. So I'm taking this quadratic. I've got ax squared plus bx plus c, and then the x minus 3 I'm setting down here. I know that the d is 0, so I don't need to worry about that. So we can just ignore that d because we've worked out that that's 0. So because when I expand this out, and if you're unsure, the best thing to do is take this grid and just expand it out and have a look at what terms you get in each of these boxes. But when I expand it out, the only place that I can get x cubed from is this box here. So when we look at x cubed, we know that it has to be 1x cubed, therefore a needs to equal 1. And I can progress with the next step. So you would do this all on one grid, but I've done it on multiple grids just so that you can try and see the process. Because I now know what this is, I know that it's 1x squared, I can fill this box in here. And I do that by multiplying those two things together. So when I get that, I get minus 3x squared. For x squared, I want 2x squared, and the x squareds in this grid are going to come from this diagonal. If you just look at it, expanding it out, this one's going to be an x term, this one's an x term, and this one's a constant. So these are the only two where I can get the x squared from. I want 2x squared. I've got minus 3x squared, so I need to add 5x squared onto this in order to get to 2. So I know that that term there needs to be 5x squared, and that's just looking at what I want and what I've got. If we look at the next grid, because this is 5x squared, that tells me b is 5. We do need to be careful here. If the coefficient of x in this divisor is not 1, then I do need to think about what this number is. It's only matching this number here because the coefficient here is 1, and I'm doing this times this has to equal this. So you might have to do a bit of division at that point. I'm sure you'll come across that as you're doing more questions. So the next thing I'm going to do is fill in the part of the box that I know. So I get minus 15x from here just by multiplying that. So focusing on the x terms, I want minus 17x. I know that the x terms are going to come across on that diagonal. So because I want minus 17 and I have minus 15, I need to take 2 more x off. So I need that to be minus 2x. Therefore, this c needs to be minus 2. So the last grid that we need to look at is that one, and expanding the last part of the grid we get a plus 6, which we can check works, and then that leads us to that final answer, which is exactly the same as what we got with the other method. You may find you can start taking shortcuts with this as you get more practice, and definitely with the other method you can start just writing it down. If you're going to take a shortcut, you can work out what A and C are in your first step. Just because the way this works, just look at the colours down here. So the x squared work on the diagonal and the x work on the diagonal, but the constant term and the cubic in this example are only coming from one box. So if you started with the x cubed and the 6, you can get the minus 2 and the 1 first up, and then you've only got to really think about that middle section. if I was doing it that way, I'd maybe look at the middle section using the quadratic and then use the x term to check. As you play around with it, you'll find a way to do it efficiently. So let's do one more. Might be a good idea right now to pause the video and have a go at this, and then you can walk it through either using comparing coefficients, using the grid. I would advise you to try both of them, and then you can get a feel for which one seems easier. So again, I'm doing a cubic divided by a linear term. So I know that I've got a quadratic and I've got this plus d on the end. I'm going to see whether I've got a remainder. I need to substitute -1 into the original polynomial in order to work out what that remainder is going to be. And when I do that, this time I've got 14. So we know that d is equal to 14, which is the remainder when our polynomial is divided by x plus 1. So when I write it out, I've got a plus 14 at the end this time, rather than being able to ignore it because it was a factor before. And again, we're going to look at this by colour coordinate. So I've expanded it out in exactly the same way as I did the first time. And there are the colour codes. This time we've got 2 terms there for that constant term. If you are getting good at this, you might be able to spot what A and C are straight away without having to expand it. And if you can do that, then you don't need to write the full expansion out. What you can do is just then focus on the expansion for B, because we know that the quadratic, for example, comes from 1 times ax squared and b times x squared. So once you've got A and C, you can skip ahead and just almost do this green section. But working it out in full, comparing the coefficients, x cubed, we get A is equal to 1 again. And then when I look at the quadratic, I've got A plus B needs to equal 2. Substituting in A equals 1 and solving leads to B is equal to 1. Looking at the x term, so on the left hand side I've got -6, on the right hand side I've got B plus C, but B is equal to 1, so I substitute that in and it filters through to give me C is equal to -7. And then we have 7 is equal to C plus 14, so C needs to equal -7. So we can work out those terms as we go, and therefore we end up with that expression there. So it's written as x squared plus x minus 7, x plus 1 plus 14, because that was our remainder. Repeating exactly the same question but using the grid method. So start off in the same way, find out what d is. In this case, we know that d is equal to 14. So I can almost, if I am working with this, almost ignore that now and just replace it with a plus 14. And I'm going to focus on this section here and then worry about the 14 afterwards. So I've got x cubed. I know that a needs to equal 1 just by doing that comparison there. And then when I look at that grid, I can expand out this bottom box here, which is going to give me an x squared term. For x squared, I work on that diagonal there. That's where the x squared terms are coming from. And I'm looking for 2x squared. Therefore, I am missing one of them. So I can fill that in because that will make the green section work, which tells me that b needs to be 1. Expanding out so that I get this bottom section. That gives me x. I want -6x in terms of the x term, and therefore I need a -7 in this box to make that work, which tells me that c needs to be -7. And then expanding that last bit out, it gives me -7. I can't force that to work. Once I've got to this point, I have to go with whatever value I have been given, but that's where the remainder comes in. So at this point, I have -7. But we know that -7 plus 14, because we've got this remainder, if I was to expand this out in full, I'd still have this plus 14 sat on the end. So you can almost think, as you're doing this grid method, there is a plus 14 to go with this constant term. which if you're trying to take some shortcuts, you do need to consider that. So that plus 14 is going with that constant term, and that we can check leads to the 7 in the original polynomial, and therefore I end up with the same answer as I got using the previous method. There is a third method, algebraic long division. If you look at page 139 of the textbook, it talks you through the method. And I've also put a link on here. If you just search maths is fun polynomial division, it will take you through it on there. There'll be loads of videos on it as well on the internet if you want to have a look at that method. But the two methods that we have done will work for all of these questions. Ultimately, you need to find something that works for you. The only way to do this is to master the technique and complete multiple questions. So I've got exercise 7b here. You can go to the textbook if you want to. Bear in mind the method that will be given in the textbook if you're looking up solutions is going to be the long division method, so that third method. To factorise a cubic, once you've found the quadratic factor, you factorise that into 2 further brackets. Looking at these questions, we should be okay with question 1 and 2. It tells us how we are dividing. When you get onto 3 and 4, you're just going to have to think about it in a little bit more detail, because I've got x to the 5. So if I'm looking at this one here, I've got x to the 5 and I'm dividing by x. That tells me that I'm going to need something which has got, can't really see that very well because it's yellow, but something that's got ax4, because when I do x to the 5 divided by x, it gives me x to the 4. So it's ax4 plus bx cubed plus cx squared plus dx plus e. So it's expanding that out quite a bit. So that would be that type of bracket. So the bracket where we've got the x squared there, it's that sort of thing that you are looking for. And the same here, because we've got x to the power of 4 and I'm just dividing it by an x term, that will lead it to be a cubic. So we have some harder ones down here, and it would be worth having a look at those.